Hello, thank you for joining. We'll just give it a couple of moments to let people jump on the webinar and then I shall begin. Okay, hello, my name is Eddie Thompson and I am Lead Solutions Engineer for APAC here at Sumo Logic. And today I am going to be speaking to you about application observability and giving you a bit of a live platform demo of the Sumo Logic observability solution as well. So just to start off, a bit of a level set, some of the things we're hearing from other customers, some of the challenges that they're dealing with. They've got expanding tech stacks. Things are moving really quickly. Developers are picking up newer tools. There's a lot of stuff changing. Exploding volumes of application components, containerization, serverless, Kubernetes ephemeral components. There's just so much more things to deal with than your sort of traditional three-tier app that we used to deal with. The data deluge, the sheer increase in the volumes of data that people have to deal with now is crazy. Showing my age a bit, but I remember when dealing with a terabyte a day was a lot of data and did need significant sort of architectural challenges to meet. And at Sumo now, we're scanning in the petabytes of data every day. So it's just absolutely ramping up. Rapid pace of change. Everything's moving more quickly. People have moved through sort of DevOps, CI/CD. Everything happens more quickly. There is more change to deal with. There's a lot more to keep track of. And broadening attack surfaces as we expand our application footprints, there is greater risk. There is greater things to keep track of when it comes to security as well. And the fact of the matter is that siloed tools cannot keep up with these things which are going on. So when we talk about observability, what are we talking about? So we're talking about something which means that you can infer the state of an application from the outputs that you are receiving. And when we sort of talk about that at Sumo, we're generally sort of talking about signals from things like metrics and traces and logs. And for true observability, it requires rich data to be able to get a inference of a complex system, a distributed system from its outputs. You need a lot of data. The more data you have, the richness of that data gives you a more complete picture of what's actually going on within that system. And what we allow you to provide here is the analytics to that data to basically give you that clearer picture in a more automated fashion. And from that, be able to get from an alert from either a monitor for something known or an anomalous event to resolution quickly. So looking at sort of what we can traditionally sort of consider a funnel, but in this case is a little bit more like an iceberg. Monitoring when you're looking for alerts on high-level metrics, anomalies, so things like error rates, things like latency. These are things that you're monitoring with metrics. You see a spike in latency, you get an alert, and that's when you need to be able to sort of investigate, find out what the problem is, and that's when you sort of move into this diagnose phase here, and that's where you start to be able to leverage things like distributed traces to be able to investigate service relationships to find out what is going on within your distributed application. And finally, we get to the dark part of the iceberg, troubleshooting. And this is sort of where the volume of logs ramps up. And this is sort of being able to look into the why, look into the how. And this means being able to bring powerful analytics to bear to make large volumes of log data basically consumable at a human scale. So, Sumo Logic, what do we bring to observability? It's built for observers. So we've got a user-friendly UX and a common query language across use cases. So we haven't just sort of like taken three products that we've acquired and sort of munched them together. Sumo is a platform. We started out in logging, but we've sort of built this out over the years. So we have a best of breed scalable data platform that we have enhanced the capabilities of. And now we sort of reached the point where we consider it a true observability platform. We've got loads of integrations and out-of-the-box dashboards and alerts. Really reduces that sort of setup time. It's built for modern applications. So it's built for cloud-native applications. It's built for Kubernetes. It's built for the cloud. It's built for visibility into microservices architectures, making it really easy for you to onboard that data and sort of get a feel for how your application actually is structured and how it is performing. And also being able to sort of correlate across those various sort of data sources and signals to investigate when you do have a problem. Applied analytics. So one of the important things here is being able to use machine learning driven workflows, things like our log reduce when you actually have a problem, being able to go from thousands or millions of results down to a couple of pages of signatures to really key in on anomalous behaviors or what's actually causing you problems without needing to spend hours and hours poring over log lines. And golden single benchmarks, really important thing. When we take in a lot of this data, we're automatically generating benchmarks and metrics for you. So when you have your instrumentation coming in from your tracing, we're automatically generating those golden signals around things like latency and error rate and request rate, so you can actually know what's going on right down to the operation level very easily. So I was speaking about tracing data there for a moment. One of the things to remember about Sumo is we are all on board with OpenTelemetry. So if you're not familiar with OpenTelemetry, this came out of the merging of a couple of projects being OpenCensus and OpenTracing. And basically this is widely industry backed to provide a common open standard for application instrumentation without sort of black box APM vendor lock-in sort of things, which was what we sort of had with classic APM, legacy APM, whatever you want to call it. But basically it meant that if you'd instrumented with one provider, you were kind of stuck with them. If you wanted to move, then it was a forklift upgrade to sort of go through and re-instrument your code base, which was generally a lot of effort that people didn't want to undertake. The big benefit for OpenTelemetry is that if you instrument with Sumo's OTel library is great, but if you use the AWS distro, great. If you use the OpenTelemetry upstream, great. We support it natively. You can bring all that data in and we're going to treat it just the same. So we'll jump into a demo pretty soon here. I'll give you a little bit of a overview of sort of what I'm going to show you and then run it through you live. I promise I'm not going to bore you to death with slides here. So what I'm going to show you here is an application that's basically a coffee bar. So it's a cafe and it's got some options for people to buy things like espresso, a cappuccino. They might want a muffin or a croissant. And it's a fairly simple application. It's built to display some microservices and the various service relationships in an easily consumable fashion. So we've got application components like DynamoDB. It's running some Kubernetes containers. There's some Lambda functions. There's some EC2 VMs, and this is all running on AWS. So there's a couple of things here. We've got some various microservices. We've got a front end service which the user can log into, make their order, and then it fires off some requests to some back end services. So we've got a machine service which calls the coffee service and the water service. We've got a payment system which hits up a SQL database and a calculator service. But basically, you can see that there are consistent requests flowing through into a distributed application. So I'll jump over now, and this is the Sumo Logic service map. And as you can see, there's a bunch of those services that I just mentioned. We can see there's the front end. We can see I've got a couple of Lambda functions running here. I've got my coffee machine service, my coffee service, my water service. But the thing that's probably drawn to your eye is the fact that these three services are showing up as red, and that is in the legend that there is an anomaly. Now, the size of the circle shows you the relative requests per second, but I can see here on the front end that there is an anomaly for latency, and it's quite slow, so it's nearly 2 seconds, and that's 47% over my threshold. I can see that's passing on. The request to the next service is the coffee bar, and that's well over threshold as well. This is making a request to the coffee machine, and yep, I'm still well over my latency threshold. But after this point, I seem to have dropped off to my normal latency. So there's something happening here in the chain. That's my sort of automatic inference that I gain. And that's something that's really powerful because I didn't have to define any of these service relationships. This is all automatically generated by traffic that has been traversing these services over the last 72 hours. This map has generated. So the last 3 days, it's going to show you every service relationship that's happening within your distributed environment. And that's hugely powerful when you have highly ephemeral environments and also environments with high development velocity. Things are changing all the time. Really, really powerful to be able to see this dynamically and understand what's going on. So I'll go to the point where I'm having the issue here, and I can click on it, and this pops up our Entity Explorer. And this is going to show me some golden signals and some spark lines. And these are some of these automatically generated metrics I was speaking about. So I can see my spark line for my latency, and I can see a couple of little peaks there. I can see my request rate and my error rate. Now, if I wanted to sort of dive into this with a bit more detail, this is where I can sort of pivot between some of the additional services that we have. So I'm going to jump into the entity dashboard here. So you can see here it's automatically sort of filtered in some various filters for me by clicking in. So I can see my metadata for the application, the service, and I can also have some tuning things like the outlier window I'm using and the number of standard deviations from the mean and what sort of latency type. So this is looking at the raw latency, but I could also look at the P50 or the P95 or even the P99 if I was looking for a specific percentile outlier and I'm chasing a little bit more sort of a hard to find type problem. So we do also compute all of those percentiles as well. So at the top line here, I can see what's been going on with my latency and the spark line, my request per second, and my error rate. I've got my dependencies for this coffee machine service, and I can see a list of related traces. Now, if I scroll down, I can also see what's been going on with my latency over time, my latency last week, what's been going on with my request rate, my error rate. So requests and errors, they're sort of within normal bandings, but latency, I've got a big spike here, and the little triangle, that's an outlier. So it's basically popped me an automated alert sort of to say, hey, this is outside the normal statistical bounds of what we expect for this. This is something you should look at. So I can click on this particular point, go to the related entities. So I can see here, yeah, there's that little particular spike in my latency. And I'd say, okay, let's investigate this a bit more closely. We can go into the traces. So this is automatically filtered down for me, and you can see that I'm on a really tight time window here. So I'm only looking at a couple of minutes. So I've been able to use those dashboards, use those graphs to really hone in quickly to a specific time range to make sure that I'm filtering down as much data as quickly as possible, so I'm not wasting my time chasing my tail trying to look through things which aren't relevant to me. So I've got the option here to filter down some things a little bit more. So let's start with, I might just say I'm only interested in traces which have errors. So I'll drop away anything that doesn't have errors. And so what this is letting me know is things like my trace ID, what my root service was, what the root operation was, so what actually started the trace. And I can see here it says click on pay, when it started, total duration, the number of spans, and importantly here, the duration breakdown. So this is actually showing me the contribution to the total critical path from each of the services, number of errors, and the overall status. So if I want to click on the top one here, and this brings us into a trace graph. And I'll point out some of the things which are important here. So we've still got our filters here. We've got a little toggle, which is really handy. So error spans only. So if I turn this on, we can see the red line at the top. That dictates that there is an error on the span, and it allows me to visually sort of follow the line of the error. So over to the left, this is the time that each sort of span is taking. So a trace is combined of multiple spans, and these are the timings for each operation. And so I click on the first one here, excuse me, and this is related to the service, the coffee bar front end, and we can see that the operation is click on pay, and I jump into the metadata here, it gives me a bit more information. So I can see that this is actually a real user monitoring trace. So this is actually browser level instrumentation. So I can see what the user is actually doing. So this is actually starting from when the user clicks. So I can see it was a click. I can see that what the target element was, the XPath for that element, and I can see it's been the WebJS OpenTelemetry SDK is what's generating that information. And I see it's coming from a Chrome browser on Linux. Now that's really useful because we're seeing the entire sort of state end to end for what's going on. We're not just sort of tracking the back end here, we're getting the entire user experience end to end. So from that initial click, we can see that there is a post request, and we'll go back to the summary here, and we're getting a 402. So there's a problem somewhere along the line here. So we can follow that down. There's an order. We can see the order is persisting that 402 down. But basically, we can see when we turn the error spans on where this is persisting. So it's going off and it's getting a coffee. It's making a request. If we zoom in, we can see that it's preparing a coffee, and it's getting some beans, it's getting some water. That's all working fine. So what we need to do is have a look over here at where these errors are. So we can zoom in a bit and we can see that there's a request here going to the cash desk to pay in, and we're getting I can see here there's a span event. So there's a span event with 2 attributes, and so we're getting an exception, which is 402, and it's saying the reason, not enough money. So someone has tried to pay and they've had insufficient funds. Now, this is really handy here because we can see that these come up in what we call as span events. So this is where it tells us useful information like fetch start. So this is where it actually started to get the actual request back from the browser. Now, and I can see here response end when we sort of finish loading there. But what I've got here, this exception, it shows me really quickly what's going on. Now, I might want to investigate this with a little bit more sort of detail, and that's where we can actually really easily pivot to the underlying logs. So I'm going to open the logs tagged with this particular span ID. And so this is so powerful, being able to pivot directly from the logs, from the traces that I have, that instrumentation, to my sort of source of truth, the record of actually what happened in the logs. Because that instrumentation library is injecting a trace ID and a span ID, I'm able to hook that into my logging library and make sure that I'm able to directly correlate these in an automated fashion. And OpenTelemetry makes it really easy to do. It's not like you have to go and code up a heap of stuff. There's generally like really easy to use logging library exceptions. So I can see my sort of whole sort of follow through for this particular trace. So for this span, it's making payment in product, getting a product price, calculating total price, calculation result, getting a product price, calculation result, and finally, payment failed. So the error, the actual exception, is what shows up in that in the span events, because that's an exception, that's something unusual. But yeah, we can drill down and actually get the underlying complete context from the logs. And yeah, as I mentioned, it's just something that's so powerful, being able to start at a service view and see a high level anomaly, just something showing up that says, hey, your latency is high. Being able to pinpoint where that actually is happening via some dashboards, being able to sort of investigate those service relationships, really quickly drill into where the errors might be showing up and what the problem might be, and then being able to have that really high fidelity level of context at the end with the full set of logs available to you. So yeah, that's sort of a quick run through on application observability and instrumentation with Sumo Logic, and how we're sort of able to tie together those logs, those metrics and traces, and in a really automated fashion, get you a high level of application observability out of the box, really easy to do, and yeah, basically really improve your experience when it comes to monitoring and troubleshooting in your modern applications. So really appreciate you taking the time today to come and check this out. As I mentioned, my name's Eddie Thompson. If you are interested in taking this for a ride, please jump on the Sumo website, fire up a free trial. If you're interested, yeah, we're more than happy to have a chat with you. and help you out with your application observability challenges. So thank you very much, and I shall see you next time.